Alright, good day viewers. Happy to meet you again. This is another wonderful time of lectures. Today we're going to be having quadratic equation as a topic. We'll continue from where we stopped in the previous lectures. Today we'll be looking at equations with irrational roots. Equations with irrational roots. Before now we have looked at general form of quadratic expression, and then we've made some few calculations. You've learned how to get the factors, all right, and then solve. But today we're going to consider this equation with irrational roots. What I mean is this: if we have, say, we have x squared equals 16 rather. What are you going to tell me? You will say that you're taking the square root of both sides, so you can get your value of x. So x is equal to the square root of 16. Why is this so? If you take the square root of the square of x, it's going to delete the square out of it, and then you have your x. Then when you take the square root of 16, of course, you will get the value 4. Or can I just say you're going to get plus or minus 4? Okay? And the reason why you have the plus or minus is because of the square there. So x becomes plus 4 or minus 4. Alright? Okay, let's say we have this example. Let's say we have example now, x minus 3 all squared is equal to 16. How do you solve this question? You're going to solve it the same way. Alright? So x minus 3 all squared equal to 16. Let's see how we solve this question now. These are irrational roots. Let's see something here. Alright, so the first to do is to remove the square by taking the square root of both sides. Alright, so when you do that, you have, if I take the square root of everything here, this square goes away. So you have x minus 3 equal to the square root of 16. You get that? So the square root now has helped us to delete or eliminate this square. They will have x minus 3. And then on the right hand side of the equation, you have root 16. Alright? So the next thing to do is to carry minus 3 to the right hand side. So you have x equals, minus 3 comes to the right hand side, becomes just 3. And then because of the root sign, you show plus or minus the square root of 16. So x is equals to 3, okay, plus or minus 4. So you have the two values now. But the square root of 16 is 4. So you're going to have x is equal to 3 plus 4, or you're having 3 minus 4. Why? Let's take a plus or minus sign. I'll explain. X equals 7 or minus 1. So these are the two values you're going to have as your x. Okay? Now why is it so? Why the plus or minus sign? The plus or minus sign, if I give you root 16, it's actually plus or minus root 16. Okay? Because this will give you plus minus 4. Why? Because two values multiply. So if you say plus 4, multiply plus 4. Of course, you're going to get 16. Because you know, plus multiply plus, that's plus. And then 4 times 4, that's 16. Okay, if you start to take negative value, you have minus 4, multiply minus 4. Of course, you have minus multiply minus, that's already plus. And then 4 times 4, that gives you 16. So you see, we're using the plus or minus sign when solving. Alright, so this is just a basic introduction to this. Now let's take something more similar to this now. Let's say x plus 3 squared equals to 7. Now look at this example quickly. Alright, I believe you're okay with this, number 1. You're okay with this, number 2. Alright, let me take 3 side now. Number 3. Let's say we have examples like x plus 3 squared equals to 7. Let's say x plus 3 all squared equals 7. The same process, of course. Take square root of both sides, you have something. You have x plus 3, sorry please, this is squared. Okay, x plus 3 comes down because take square root of both sides. You have the square root of 7. Okay? Then you're going to bring what? Plus 3 to this side. That's plus 3 changes to what? Minus 3. Then you're going to put plus or minus the square root of 7. Then you walk these two sides and you have x equals minus 3 plus root 7, or you are saying that x equals Sorry, let me just, okay, that's minus 3 now, minus root 7. Okay, now because this is actually irrational, you can stop here, or you take your calculator, get the value of root 7, then you're going to remove 3 from it, get the value of root 7, you remove what? Minus 3 from it. Sorry, minus 3 out of this, minus 3 minus this root, so that gives the value. So you can conclude like this by saying x minus 3 plus root 7, or minus 3 minus root 7. You can stop at this level. That's very okay. Okay. Now, this is a simple way of doing it. There are many examples you can take. Let me draw some few examples with you. You can calculate. Okay. So you can write this down as your assessment and see if you understand what I'm saying. All right. So you do this for yourself. Quickly copy it now and see what you can get. X plus 1 squared. Quickly copy this. 1. X plus 1 all squared. Okay. Equating to 2 1 over 4. 2 1 over 4. Please copy this quickly. Then number 2, you can take a value as x minus 4 squared equal to 10. X minus 4 squared equals 10. Alright, this 2 is okay for you. Okay, so we'll now move on to the next level, looking at the what we call the completing the square method. Completing the square method. Alright, now this method is not easily understood by students, but let's see how we can get it right. You go to some exam questions in your quadratic equation. You will see questions like, what can be added to this expression to make it perfect square? It comes out in your exams all the time, your SSC exams, YEC, NECO, GC. What can be added to this to make it the perfect square? Okay, let's see something like that. So we call it completing the square. I will do this and later take you to the real way of solving a quadratic expression using the completing square method. Let's see something now. Okay, so let me write this already now. Completing the square method. Please do well to get your assessment done. Completing the square method. Okay, simply say completing the square. Alright, now what must be added to x squared plus 6x to make the expression a perfect square? This is already a question for us now. Example now. What must be added? What must be added to x squared plus 6x to make the expression a perfect square? Now this question is really simple, but not all students understand how to go about it. Alright, now there are two ways to solve this problem. I will show you the two ways. Choose which of them you think is okay by you, or let's say which of them is easier to actually understand. Alright, let's see what we can do. Where's the expression right now? We're looking at x squared plus 6x. Okay? Now, what can you add to this expression? Let's solve now. Solution. X squared plus 6x. What can I add to this expression to make it a perfect square? That's the question. Alright. Now, what do we do? Let's take that expression. Let's consider the expression as k. Alright? Consider the expression as k. So, if I bring x squared plus 6x and I add k to it, so I'm taking the expression as k. Alright? And then I equate it. I take this k now as a constant I'm looking for, right? Then I equate it. Then you take another constant of your choice. Another constant of your choice. Let's say constant a, for example. Open the bracket, put a. This a now is a constant of your choice. Okay? And then you add it to the variable. What's the variable in the question? The variable in the question is what? X. You can see x squared here, you can see x. So x is the variable in the expression. Alright. So add it to the expression now, that's plus x. Or possibly, let me just put my expression variable first. Let's put the variable first, x. And I bring my own constants. The same thing. I could have said a plus s or s plus a. They are all the same thing, please. Alright, and then you square it. Okay, now how do you see this? Very easy. So we'll start from here. You understand what I did? This expression, x squared plus 6x. So they said, what can I add to this to make it a perfect square? So let that value be k. So add it plus k. Equals. Then bring in the variable in the equation. The variable in the equation is what? X. I put the x in the bracket. Plus, I added my own constant. Alright. Now, I square everything. So what do? We start expansion. Alright, so if you take this value, that is, let me bring it under here, please. That's x plus a all squared. You're going to have what called x plus a into x plus a. If you expand, what do you have? X multiply x give you x squared. X times this give you what? Give you ax. X times they give you ax. Then a times s give you as also. Then you're going to have a squared to end it. So this expression. Then finalize to say x squared plus, how many ax do you have here? You have 2 of it. So ax. So it's going to be 2ax plus a squared. Okay, this expression is this. So you cannot equate. So you have x squared plus 6x plus k is equal to, bring it up. You have x squared plus 2ax plus a squared. I believe you're following me. Okay, now we'll now do what we call comparison. Let's compare now. This expression on the left hand side, this is a constant k. Then the expression on the right hand side is your a squared. Don't forget that you are the one that introduced this a squared. Okay? Then you now do comparison of the coefficients and comparison of the constants. What is the variable again? The variable is x. What's the coefficient of the variable? The coefficient of the variable is plus 6. So now come to this side. What is the variable of this expression on the right hand side? It's x. What's the coefficient of the variable on the right hand side? It's 2a. Look at this. 2a is the coefficient of the variable on the right hand side. Y plus 6 is the coefficient of the variable on the left hand side. Alright, so compare coefficients. When you compare, what's going to happen? That means 2a should be equating to 6. And you see that a becomes, a becomes 3. Are you getting it? Alright. Then at the end of the day, you do what called comparing of constants. Okay? Comparing. If you compare constants, what do you have? Don't forget that k is the constant of equation, the left hand side of the equation, and a square is the constant of the what? Right hand side of the equation. So then we can say that k is equal to a square, right? Okay, what's the value of a? 3, right? So k becomes what? 3 squared. So k is what? 9. So can we say that 9 is a number that you should add to this expression to make it a perfect square? Okay? Alright. Now, how do you do that? Let's see something. Okay, if you bring it back now, you're going to have x squared. Watch this now, please. You have x squared, right? Plus 6x. What's the k now? 9. So, plus 9. So, I've added 9. So, this expression now is a perfect square. How do you know that? Very easy. Alright. What is this expression you have here? X plus a squared, right? Now, what's your a value? 3. If you bring it there and do something, see now, check it out. What do you see? I will say x plus a is 3 squared. If you expand this, you have this. Can we do that now? Okay. So x plus 3, x plus 3, x plus 3. Can we expand? So x times s is x squared. X times 3 is what? 3x plus 3 times x is 3x plus 3 times 3 is 9. So x squared, when you add this to what you have plus 6x plus 9. So you see that what you have here is what you get here. That makes this expression correct. So in statement you say, the value to be added to the expression make the perfect square is 9. What is the other method? Before I round off. The other method of getting this is very simple. Let's go to the side. Maybe you want to use this method. There's a formula for it. And what's the formula? The formula is called b squared equal to 4ac. B squared equals 4ac. Okay? Now, let's see the method we can apply here now. Okay. Now, at this junction, let's see what we can do. Recall that we have ax squared plus bx plus c as a general form of every quadratic expression, where the c becomes a constant. Now, collect that expression, we have x squared plus 6x. Then don't forget that you are the one that introduced the k to be the number to add to make it a perfect square. So that's plus k. So this k is what we are looking for right now. So this is the number I'm adding now. Okay, now let's go quickly. In this expression, ax squared plus bx plus c, general form of every quadratic expression. Now, from here you discover that we can do a comparison quickly from this expression with this expression and this expression, alright? Because they look alike. So, what is the coefficient of this expression of x squared here? Coefficient is what? 1. Okay? What is the coefficient of x squared here? A. That means a is equal to 1. Now, what is the coefficient of x here is 6. What is the coefficient of x here is b. That means b is equal to 6. What's the constant here is k. What's the constant here is c. That means c is equal to k. Then by the formula, which is this, bring it down. B squared is equal to 4ac. Where's your b? 6. What's this here? 6 squared is 4 multiplied by 1 multiplied by k. What is 6 squared? 36. 4 times 1, 4 times k, 4k. Divide both sides by the equation of k. Of course, you know that 36 divided by 4 makes what? 9. So which method do you think is easier? Make a conclusion. Alright? And then you know that this is no problem. Can I give you work to do while you test yourself? Okay? Now, what must be added to d squared minus 5d? What must be added? You do this yourself now. What must be added to d squared minus 5d to make the expression a perfect square? Okay, so it's a question now, so I put a question mark. So this is it. So do that for yourself now and see if you understand what we just did together. So what can you add to this to make the expression a perfect square? I would like to take one more example before we round off today, so that you don't get confused with some certain questions that go with fractions. So the last question now, I may not write the full questions in detail, you know what I'm saying already. What can you add to this to make it a perfect square? Okay. Now I'll drop an expression now, we solve it, then we'll now see what we'll add to make the expression a perfect square. Then from there, we can now graduate into looking at the difference of two squares in details. Alright, so one more to open your eyes and get more understanding. So I will take expression n squared plus 1.5 n. Let's see something here quickly before. I hope you've copied this already. Okay, so I will use the formula method because most students find it very easy. Okay, so now let's bring our k into it now. So what will be added to this to make the expression a perfect square? So that's plus k. Okay, then I will quickly bring down to say, but your expression, your quadratic expression says ax squared plus what? Plus bx plus c. Beautiful. Then recall the formula. Note that b squared is equal to 4ac, right? And if b squared is equal to 4ac, what do you have? Okay. Now compare quickly. From what you have, you discover that the coefficient of n squared is the same thing as your x squared. Okay, so a is equal to 1. A is 1. B is the coefficient of what? X here. So your n is your variable, right? So we'll take b as 1 over 1 over 2. Okay. Of course, your c becomes your k. Alright, so we can say a is 1, a is 1, b is 3 over 2, and c is k. I think that's okay for now. So recall quickly. What's your b now? B is what? B is 3 over 2. Put it here. You have 3 over 2 all squared. Equals 4 times a. What's your a? 1 times your k. Okay, I think we are good to go. So 3 squared, of course, the 3 over 2 is being affected by the square. So 3 squared, 2 squared, right? Okay. 3 squared, 9. All over what? 2 squared is what? Is 4. Alright, so what do we have now? 4k. 4k. Okay. Cross multiply, right? Okay. So what do you have now? Quickly. 4 that's a 16. K is equal to 9. So k is what? 9 over 16. This is value. So 9 over 16 is the value you add to this expression to make it a perfect square. So you can see how simple it is. It's not very difficult. So we will quickly jump into the next session, okay, shortly, and then we'll look at difference of two squared. How do you solve quadratic expression using difference of two squared? So let's go there now. Okay, like I said earlier, we want to look at this method, which we call the completing the square method. Okay? Now, check the board. It says solve the equation a squared plus 3a minus 2 equal to 0. Before we look at it, if you are solving a quadratic expression and you discover that the left-hand side of the equation cannot be factorized, you discover that it cannot be factorized, you either use this method, completing the square method, or use the quadratic formula. We're not going to quadratic formula yet. We'll get there. Okay? Now, solve the equation using completing the square method. Because this expression now, you can't factorize. So, what do we do? Go with me. The first thing to do, you know this minus 2 is a constant. That's the first thing to do. Carry it to the right hand side. So x squared plus 3a is 2. Once you do that, then you ask yourself a question. What is the coefficient of the variable? What's the variable? The variable is a. The variable is a. So what's the coefficient of the variable? The coefficient of the variable is 3. Okay? If it's 3, then divide it by 2. If you divide it by 2, 3 becomes 3 over 2. Okay? Then square it. If you square it, it's going to give you 3 over 2 all squared. Permission, please. Okay. So this is what you have. I picked the variable 3. I divided by 2, that's 3 over 2. I square it, that's 3 over 2 all squared. When it's done, you add it to both sides. Okay, let's do that now. So I'll take this in, I'll add the left and the right hand side. So a squared plus 3a, break it down, plus 3 over 2 all squared. This is the left hand side now, done. Equal to 2 plus 3 over 2 all squared. This is the right hand side, done. Right? Okay. Now, what do you do again? You take a value, your variable, take your variable, a, bring it down, open the bracket, plus, you take this, which is your coefficient of variable, as if you are starting all over, you divide it by 2, again, that's 3 over 2, close the bracket, you square it. Then you're done with this side. Equate it to this side, that gives you 2 plus 3 squared is what? 9 over 4. 3 squared is 9, 2 squared is 4. Okay? That gives you this. Alright. So you have a plus 3 over 2 all squared equal to this. If you take the LCM, normal LCM, if you work it out, you're going to get SM4. This is over 1. Okay? So 1 into 4 is 4, 4 times 2 is 8. 4 into 4 is 1, 1 times 9 is 9. When you add 9 plus, you can get 17 over 4. So on the right hand side, you're adding 17 over 4. Alright, everything now gives you 17 over 4. The next thing to do is this. How do I remove this square here? To remove this square, you are going to take the square root of both sides. Right? Okay, what do you have? You have a plus 3 over 2, close brackets, okay, equals to the square root of 17 over 4. Alright, so this is supposed to go out of it, please. Okay, because we are going to square already, the bracket is open. Okay, now the next thing is to carry the plus 3 over 2 to the right hand side. So you have a is equal to minus 3 over 2 plus or minus the square root of 17 over 4. This is what you have. You know why the plus or minus coming because of the root sign. Alright? So, what do you do quickly? The answer now is very obvious. Don't forget that 4 is a perfect square, 17 is not a perfect square. So you're going to have something like this. A is equal to minus 3 over 2. You know how the minus came? Because there is plus. Okay, plus or minus. Then root 7 is, of course, cannot be gotten. It's perfect square. Then square root of 4 is 2. So this is what you have. So you take the LCM. A becomes what? The LCM now is what? Is 2. Go. 2 into 2, 1 times this is 3. Plus or minus 2 into this is what? 1. 1 times what? Root 17. So this is what you have. This is the final answer. Or you may decide to say, okay, I want to take it decimal. No problem. You can say, okay, split it. You say a is equal to minus 3 over 2. Then you take the positive side, that's plus root 17. Okay? Root 17 over 2. You work that separately. You say, or a is equal to minus 3 over 2 minus root 17 over 2. So you work it separately. Okay? When you work this side, what do you have? You say, okay, come down. If you bring this side down, further, you have something like this. That is the LCM 2. You have minus 3 plus root 17. That gives you your answer. Then this side, if you work it out, you have minus 3 minus root 17 all over 2. So this is the final answer you get. So get the square root of 7 minus 3 plus that value divided by 2. Get the square root of 17, this is 17, I'm sorry, this is 17. Get the square root of 17 minus 3 minus that value divided by 2, that's the two values of x. So this is the square root of 2 squared. It's not as difficult as you think. Okay, so I will not leave you without dropping one question with you, and then you will go and solve it and see, follow this method, very simple. Okay, now let's look at this question. Solve this expression using the completing square method. B squared minus b minus 12 equals to 0. Assessment now. Solve this thing using the completing square method. B squared minus b minus 12 equals 0. Solve this expression using completing the square method. Okay? Now, or let me see, give you the c squared minus 4c minus 2 equals to 0. C squared minus 4c minus 2 equals to 0. Like I said, don't forget, if I round off, that if you cannot factorize the left hand side, please use completing the square method. If you can factorize, wonderful. I will see you in the next class. There are other things you need to know about quadratic expression. Thank you very much for viewing. God bless you.